simplify this expression. So before I tell you the rule, how could I write this out using repeated multiplication? X to the fifth just means x times x times x times x times x. X cubed means x times x times x. How many times is x actually getting multiplied by itself? 8, right? X to the 8th. So if x to the 5th times x to the cubed is x to the 8th, the rule is whenever you have the same base, you can add the exponents together. And if you forget, just write out your repeated multiplication and just verify, oh yeah, I should add them together. Does that seem familiar? Like you've seen that rule before, I hope? All right, so then the kind of opposite of that, the product rule is the quotient rule. So now you're dividing two exponential expressions that have the same base. So here's what would happen if you multiply out x to the 4th on top and you multiply out x cubed on the bottom. How many of those x's actually cancel out with each other? 3 of them do. So you end up with just a single x that is in the numerator, or x to the 1st. So what did I do? I took this 4, I subtracted 3, and I got x to the 1st. So it would be a, and I'm taking n, subtracting m. So if you're multiplying, you add, and if you're dividing, you subtract. But if you forget, just write out your repeated multiplication and cancel them out. So you'll have these rules to look at when you're doing the guided practice on the next page. Okay, and then the power rule, this is the one that tends to confuse people because up here we had to add them together. Down here, do you remember what the power rule is when you're distributing? Repeated multiplication, this tells me to do x squared times x squared times x squared, which is x to the 6th altogether, because this is xx, xx, xx. So I have x to the 6th altogether. Oops, I should have written x to the 6th over here. So what's the rule? I actually took 2 times 3, right? So a to the n times m. So see how collectively, when you take these 3 rules, like all together, it's hard to remember which is which. I'm trying to zoom out for you. There you go. And then the last one on this page is the distributive rule, which just means if you see a parenthesis, you have to distribute it to every single thing inside the parenthesis. So you actually are going to distribute to both of the bases, even if there's no exponent there. So this is actually a to the nth power, b to the nth power. Just like over here, you would have a to the nth power over b to the nth power. So it gets distributed to every single thing inside the parenthesis. Sometimes students miss distributing it to every single thing. Like on this next example, you might be tempted to skip over the leading coefficient, but that also is getting squared. So you really have 3 squared x to the 6th or 9x to the 6th. And you could prove it to yourself because what does squaring a number do? It multiplies it by itself, right? 3x cubed times 3x cubed does give me 9x to the 6th. So if you're ever questioning it, write it out as repeated multiplication. What would I get on this last one? I'm distributing the 3. We already said the distributive property is it ends up multiplying the exponents. So it would be what? X to the 6th over y to the 12th. Yep. So you've got those 4 rules. And then on the back page, it's going to review for you the negative exponent rule, which we kind of talked about yesterday, and the 0 exponent rule. So when we were graphing them yesterday, we kind of already talked about this. But basically, if you have a negative exponent, it takes the reciprocal of what you have. And so I'm kind of going to prove it to you. So why does that actually work? So this says, let's figure out, let's do some repeated multiplication and then cancel. So if I have A over 1, 2, 3, 4, when I cancel, don't I get 1 over A remaining? Because that A is left in the denominator. All right, what if I did it the same way, but I used the quotient rule from the front page? The quotient rule said I take 3 and I subtract 4. What is 3 minus 4? -1. So basically, this isn't a proof, but I just showed you that those are the equivalent ways to write the same thing, right? This started out as the same problem. I used my repeated multiplication, I used subtraction, and guess what? Those are equivalent to each other, and that's what I just said the negative exponent rule does. It takes the negative exponent, flips it over, and makes it the positive reciprocal. So if I was going to rewrite 45 to the negative first power, that's just 1 over 45. And if I want to take x to the negative second power, that's 1 over x to the positive second. So when you move the negative, it becomes positive. If it starts out negative in the denominator, you move it to the numerator to make it positive. All right, and then the last rule on here was just, hey, anything to the 0 power is always equal to 1. So anything, whether it's a number, a constant, a variable, anything to the 0 power is 1. Here's my proof for you, or explaining it. Let's use repeated multiplication. A over A. Cancel, cancel, cancel. Anything divided by itself equals 1. So that equals 1. Then this says, let's simplify the same expression using the quotient rule. What is 3 minus 3? 0, right? So if a to the 0, right, because 3 minus 3 gives me a to the 0 power, has to equal 1, I'm just showing you that those are equivalent, and it's equivalent for everything. So whether it's 12 to the 0 power, that's 1. X cubed y squared to the 0 power, that's 1. So don't overthink it when it's to the 0 power. Just cancel it out and say that is equal to 1. So I'm going to give you about 5 minutes or 10, whatever it takes. I'd like you to practice evaluating expressions, simplifying, go through them slowly. Try to get 100 on doing all these manipulations. These rules are important because sometimes you need to simplify an expression before you can solve it, graph it, whatever. So you need to simplify correctly to do the next step of what we're learning. 5 to the 5th. I don't know that without a calculator. Can someone tell me what 5 to the 5th is? Okay, and you guys know on a calculator how to change the power, right? Because some people like square it and then delete the squared to put a 5, but you could do 5, and then it's this upside down caret symbol under the clear button. So then you could just do 5 raised to the 5th in one step, 3, 1, 2, 5. 16 squared is what? 256, 216, and what is it? Okay, and you could have looked at your power family chart for that one. So let's see, in this one you should have added them together, right? So d to the 16th is your final answer. Add them together, so a to the 19th. Add them all together. So is that 42? Is that what you got? Did we do okay on that? So I think when you use the same rule in a row, it's easy. But when you start jumbling all the rules up, this does get challenging and you'll make mistakes. So try to go through it slowly. Here is distributing, right? So you multiply x to the 6th. Anything to the 0 power is just 1. So your answer should just be the number 1. Not x to the 1st, not anything, just 1. And then did you remember to distribute the squared over to the 8 as well? It should be 64 and then c to the 10th. So you physically do 8 squared, And then here, the 5 times 2 gives you a power of 10. To me, students make this mistake a lot. They forget to square the 8. I would rather you write it as 64 personally, but I mean, I don't know. If you do it on like one problem, but if you do it like on every problem, you want to reduce the number. All right, let's see. This gives you what? 45, 6, and then you add them together to the 51st. Is that what you got? All right, so then we get to some negative exponents. The 2 technically has a positive exponent, so it's happy where it is. X to the negative 4 is not happy where it is. So you're going to move it down to the denominator and make it x to the positive 4. X to the negative 7 is not happy where it is. You're going to move it up and make it x to the positive 7. Then you can do that subtraction rule. So your final answer comes out to 2x cubed. I guess you could also use the subtraction rule at this step. Negative 4 minus negative 7 does give you positive 3. So that to me is the most challenging one on here so far. And then the same thing with 13. I personally like to move all of my numbers to make them happy exponents first, and then I simplify. So if it were me, I would move this 3 to the negative 2nd down to the denominator, call it 3 squared. Then I have x, x to the 4th, and then x to the positive 12th once I move it to the denominator. So then now I'm going to simplify my final answer. So I have a total of x to the 5th. I have a total of x to the 12th. So I have 1 over 9x to the 7th when I subtract and leave it in the denominator. Does that make sense? If I wrote this out using repeated multiplication, I would have x times x times x 5 times, and then x times x times x 12 times. 5 of them will cancel, and I'll have 7 of them left in the denominator. You need to have that 1 to have the correct answer. You can't just write 9x to the 7th. So 12 and 13 are pretty challenging. So when you do the negative exponents on your homework, just do it one step at a time, very slowly, so you don't make the mistakes. And then this was back to what we did yesterday. So what did they come out to? 20, is this 21? Because this is just 1. This is 10, 21. Okay. This one, remember, that's a negative 3x squared. So that's actually negative 9 plus 5 is negative 4. It's tricky. It's not in a parenthesis, so we leave it as the opposite of 3 squared, which is negative 9. But this one is inside a parenthesis. So this is really 2 times positive 16, which is 32. And then this one, if you want to do it in one step or 2 steps, it's 1 to the negative 2nd over 3 to the negative 2nd. So when I flip my fraction, I bring the negative 2nd to the top, this negative 2nd to the bottom. 1 squared is 1. So this is really just the number positive 9. And then let's see. When you evaluated and made this a negative 2, what'd you get? 200 times 4 to the negative 4th plus 8. What did it come out to? When you plugged in negative 2, that would give me negative 4. I think you might have made it 0. Did you get 8.78? Anyone? Did anyone try it? And then for this last one, when I plug in 1, 200 times 4 squared plus 8 was 3208. Did we get there on evaluating? Those to me would be with a calculator, because I can't do those without a calculator.